Hi everybody, in this video we will discuss about inserting at the end in a circular linked list and we will implement using C++. So let us first consider the case when the list is empty. So when the list is empty, what we will do is we will create a new node and we will make the next part of the new node to be equal to the address of itself. Why we have to make this is because the concept of circular linked list tells that the address of the next part of the last node contains the address of the first node, right? And when you're having only one node, that node is the first node and that node will be the last node as well. So we have to make this, and also we have to make the head to point to the only node that is present. This is what we will do when the list is empty and you are going to insert the only node. But just recall that we did the same thing when we were doing insert beginning operation also. So it is better to call insert beginning when the list is empty, right? Let us not rewrite the code here. If we call the same insert beginning, then it will be fine, right? That's what we are going to make, and we will be writing the code only for the case when there are going to be few nodes. So let us consider the case when there are 5 nodes, how we can achieve insert at the end. So let us have a temporary pointer and let it point to the first node of the circular linked list, and we have to move the temp to the last node of the circular linked list. So how we can move? The condition should be temp next not equal to head, right? Because we know that the last node's next part will be equal to the address of the first node, right? You will tell temp equal to temp next. So using that loop, we can come to this particular last node, and then what we have to do, we have to make the connection between the next part of the last node and this new node, right? And the next part of the new node should contain the address of the first node, because this is the new last node. We have to make this one. Let us formally write the algorithm. So the input of this operation will be the list in which we are going to perform the insertion and the data what we are going to insert. Let us call the create node function and get the address of the newly created node. That create node function will put the data in the data part of the newly created node and also make the address part to be equal to null. And in step 2, you can check if new node is null. This is the case when there is no memory in the system at all. This is a rare case, but anyway we have to check for completeness. So if new node is null, then you have to return false, indicating that the insertion is not successful, right? And the step number 3 checks if the list is empty. If the list is empty, then you have to call insert beginning and return whatever the insert beginning function returns. And this is the general case when we are going to have few nodes in the circular linked list. You declare a temporary pointer, make the temporary pointer to point to the first node, and then you move temp to the last node, right? And make the next part of the last node to have the address of the new node, and make the next part of the new node to contain the head. These are all the steps that we have to follow. Let us try implementing in C++. So the header file, already we have got the declaration. Since this is object-oriented programming, the list in which we have to insert is going to come implicit. So the function will take only one argument, that is the data, which is going to be inserted, right? So you can see here InsertEnd takes only one integer, and this is the file where we are going to insert it, right? And the return type of insert will be bool, right? So let us tell bool clist insert end, and you have to pass the data, right? That has to be inserted. And let us have 2 pointers, node pointers. One is the temporary pointer, other one is going to be the new node, right? And let us tell new node is equal to new. Okay, we have to call the create node function with the data, right? And you check whether new node is equal to null, right? Since null is false, we can simply check like this. If not of new node, then you have to return false, right? And next is when the list is empty. When the list is empty, we will not even create the node, because we are going to call insert beginning, which will take care of everything, right? So let us check if the list is empty before the creation of the node, right? So if it's empty, then we should call the InsertBeginning function and return whatever it returns, right? So call InsertBeginning, okay, D. Fine, right? Otherwise you're creating the node, right, and you're checking if this is not possible, that is, there is no valid address return, okay, then you are going to return false. Otherwise we are going to make temp to point to the first node of the list, right? Temp equal to head, and while temp not, sorry, it's not to temp next not equal to head, right? You have to tell temp equal to temp next. Okay, you will move the temporary pointer, and after reaching the last node, what we have to do, we have to make the next part of the last node to have the address of the new node, right? So you have to tell temp next equal to new node, right? And we have to tell next part of new node to contain head. So new node next equal to head, right? So this will complete the insertion at the end, and we are going to return true, indicating that it is a successful insertion. Okay, we have to compile the code and check, and then we have to execute. In the application file already I have written the line for insert at the end. Okay, so let us compile and check the code. So we have to give G++, okay, the file name and only compilation. So give -c-o to redirect the object code into cll.o, right? And then we have to compile the application file, right? And only compilation output redirect to clla.o, right? That is also successful. And we have to link both the object files, right? And then you call a.out, right? Now we are seeing 4 3 2 1 5. Let us see what will happen when insertion is being called in this order. Insert at the beginning, you are telling 1, right? So 1 will be the only node. Then you are insert at the beginning 2, right? So 2 will come before this, and insert beginning 3, so 3 will come before this. Insert beginning 4, right? So 4 will come before this, and InsertEnd 5, right? So this is the order we expect: 4 3 2 1 5, right? We can do one more thing. Let me change this also to end, right? Let's try that. So if this is end, then what should be the order? First, sorry, 1 minute, yeah. First I'll be inserting 1 into the empty list, beginning, 2 beginning, right, and then 3 beginning, and then 4 at the end, and then 5 at the end. So I expect this to happen. Now we have to compile only the application file, that's enough. Then link it and then run it. So 3 2 1 4 5, okay, done. And one more thing we will check whether it's working properly for InsertEnd is working properly for empty list also. Of course we are calling InsertBeginning, but once let us check it. Okay, so how it will work? First you are telling InsertEnd 1, right? And then InsertBeginning 2, InsertBeginning 3, InsertEnd 4, InsertEnd 5, right? So the order should be 3 2 1 4 5. That's working fine. Okay, so the code will be shared in the GitHub. You can try it by yourself. Thank you.